Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo. All right, good morning, everybody. Can you all hear me? Happy TESCO Tuesday. We are back for another edition here. We're going to get started shortly with shop testing today with John Greenwald, our sales manager here at TESCO. Hey, John, how are you?
Hey, Andy, I am good. How are you?
Go.
Yes.
I'm doing fantastic. We got another TESCO
Great.
Tuesday coming up. But first, we have some questions from a previous presentation to address with you guys. We told you we'd get some answers. We are back. It was actually during our ratio, burden, admittance, and DMAG testing session with Rob Reese. And I believe, Rob, you are on the line.
Yes, I am, Andy. Can you hear me all right?
I can hear you A-okay. So we had a couple questions come in during your presentation. Do you want to go over them? The first one was, what effect does DC component have on the accuracy of a CT?
Yes. But before I answer the question, as I stated a couple weeks ago, these questions I didn't know off the top of my head specifically. And so this was an opportunity for me to learn something as well. So the answers that I'm providing here, I told them that I would just give them a quick shout out for their assistance here. These actually came from John Renee of Take Demand Utility Products, a transformer manufacturer, and our sales rep, Jeff Moore, out of Chicago. And so they were gracious enough to provide the answers to these questions. The answer to that first question, what effect does the DC component have? The answer to that one is any residential DC voltage on the primary will not be passed through to the secondary circuit and will not affect the CT's performance or longevity in the field.
All right, thank you for that. And then the second one is derating CT capacity for higher ambient temperatures standard practice across utilities?
Yes. All 600 volt metering CTs are designed to operate in 30, 55, or 85 degrees C. Applications are rated to 85 degrees C to take into account the high internal temperature of these cabinets. It is very rare for a CT to have a to be derated due to temperature. The only exception being maybe application. Otherwise, your CT can handle normal temperature rises with no effect. Affect the CT performance or longevity in the field. Even if the temperature above the rating for a short period of time, the CT will not be affected.
All right, well, thank you for that, Rob, and thank you again to your assistants there that were able to help you answer those. And again, if you guys have any other questions regarding any previous presentation or anything, feel free to give us a shout. We'll be sure to research it or get back to you with that as well. And regarding our presentation today, if you have any questions during this presentation, please type them into the chat and we'll address them as we go. And we'll also have a Q&A at the end. And you can get your questions in then also. And after each session, we will post a copy of the presentation as well as the video of today's session on our website, tescometering.com/tesco-Tuesdays. We'll also send out a rewind email with the presentation. If you're signed up for our email blast, you'll automatically get those. And if you're not getting those emails, just drop your name in our chat or email me directly, and we'll be sure to add you to that list. Don't want you to miss anything. And lastly, as a reminder, just kind of mute yourselves so we can hear the presentation without any interruptions, and we can hear the presenter, which is John. So any other questions, let us know. And John, if you're ready to go, we are all set.
Sounds good. Thank you, Andy, very much. And Rob, thank you for your responses to last week's question. So I think a good bit of you know me. I am John Greenwald. I'm the National Sales Manager for TESCO. I have been with the company since 1998, actually. Took over for sales for TESCO in 2008 for the brand. It's been super fun, super exciting. I miss seeing all you folks out at the meter conferences and schools. So I see some of those are actually coming back online. So we're looking forward to getting back out there in person. For now, we're still in this virtual world. So I appreciate you guys being here, and hopefully you guys get some value out of the session today and any of the other sessions. So what I was going to do, I was going to break this. We're going to talk about meter shop testing today. And I was going to basically break this down into 3 sections. I want to spend a little bit of time talking about Ansi, in particular C12.1. I'm not going to spend a ton of time on that, but just want to touch base on it. And then if you guys have any questions, pertaining to Ansi C12.1 especially, we do have a couple of folks who are on that committee that can answer those questions for you. So we should be able to get you some answers. And if we don't know them, obviously we will do as we always do. We'll go back, do some research, and get you the answer. So I don't want to spend a ton of time on Ansi today. It can be a little bit of a dry subject, but then we'll talk about 4 different types of validation testing programs. We'll get into a little bit, particularly as it pertains to, deploying new technology, right? The testing that you should be doing. And then lastly, I'd like to do a little bit of a test board demo to show you an actual live test, an accuracy test. Go through what's happening in that test and then talk a little bit about test sequencing. So I know we sort of have a wide range of folks on these TESCO Tuesday calls. Some have been, especially in this one here, some of you may have been involved with meter shop testing for 30 years. Others of you may have just come over from transmission or distribution and are brand new to it. So we try to, keep it at a pace that everybody will be good with. But by all means, as Andy said, ask questions. If I don't know the answers, I'm sure there are other folks on who can help me with those answers. And if for some reason we don't know those answers collectively, we will come back to you with those answers. So there are no stupid questions. So please, as Andy said, feel free to fire away there. So first question is, really, why do we test in the meter shop, right? Why is it that we test? And that's a simple answer. Things fail. How many of you, at some point have updated an app on your phone or, changed firmware or whatever it may be on your computer or your phone and found out that, oh crap, that screwed something else up and something else just isn't working right? So this is why we test. And, quick story for you, there was a utility that I was working with who had purchased some of our meter qualification boards, and they found an issue where if their meters, new version of their meters that they received, they had been deployed for a while, but they received a new batch of meters with some new firmware in them. And they found that if there was a small voltage blip, less than a second, kind of thing, that the meter just wouldn't recover. The meter would just completely die and they lost all communications to the meter. And they found that and were able to head that off through their functional testing program in their meter shop, and had they not done that, that could have been, 60,000, 100,000, who knows how many meters that completely were orphaned out in the field and lost all communications. So this is why we test, because again, as good as our meter manufacturers are, things do fail. They're not always perfect, and we always got to check. Things can change, right? So, why do we develop testing protocols? And it's because we want to capture all the ways that meters have failed in the past and make sure that we are rigorously checking those moving forward. That's the whole goal here, right? So utilities that aren't regulated by a utility commission typically look to Ansi for testing standards, okay? So, if you're one of the larger guys, and I know there are a few on this call, you report up to a utility commission, and every year you have to, pull a random sample of your meter population, bring them in the shop, test them, provide the utility commission with this nice full testing report of, your sample, that it was a good sample pulled across your population. But for your smaller guys, your cooperatives, municipals, but any of you who don't necessarily have to report up to a utility commission, typically you turn to Ansi for, the testing standards. So you want to be careful. And in Ansi C12.1, there's 2 sections really that we're mostly concerned with when it comes to testing of electric meters. Section 4 is acceptable performance of new meter types of electricity meters and associated equipment. Section 4, and it's really important because people get confused here. Section 4 is all designed to address the meter manufacturers. It's not really for the utilities. You can do some of that testing, and I'll show you what some of that is in a minute, as part of a FAT testing program, which we'll talk about down the line here. But Section 4 primarily pertains to the meter manufacturers, and it's the rules and guidelines that they should be following in order to put a product out that is ANSI compliant, so that the utilities are receiving product that functions well, that is accurate, and, you know, most importantly, obviously, is safe. Okay, so Section 5 is where it really addresses the utility testing. So that's your standards for new and in-service performance. And that's really what you guys on the utility end are going to care about. So Section 4, you know, they list these 44 tests. Here they are, that your meter manufacturers should pass in order to call their meter ANSI compliant. They have this list of 44 tests. And I don't know of any utility in the country, at least, that could possibly perform all 44 of these tests. You just don't have the equipment for this, right? So you may want to do some of this stuff as part of a FAT program. And again, we'll talk about that and get into a little bit more detail on FAT testing. But here's all the stuff that Ansi says these guys should do, right? You've got no load testing, variation of power factor, obviously, that's stuff that you do now. But you have things like, you know, meter losses, temperature rise, stability or performance, phase sequence reversal, high voltage line surges. If we continue on here, you see things like, you know, effective storage temperature, electrostatic discharge, radio frequency, conducted and radiated emission, you know, things of this nature. The utility just is typically not going to be able to test. But these are the things that the meter manufacturers are all testing to ensure that you guys have good product. You know, mechanical shock, for instance, transportation drop, things of that nature, right? You want to make sure that when your meters arrive on a truck stacked on pallets, that they're still going to work for you, right? So all this stuff, weather simulation, salt spray, rain tightness, all these things that obviously no utility is geared up to do full testing on. So that is Section 4. So it's really geared. So I just wanted to make that point that Section 4 is really more so all about the meter manufacturers and keeping them compliant so that they are delivering you the product. When we get into Section 5, Section 5 establishes accuracy limits, test plans, and inspection procedures that apply to all metering devices, okay? And this includes, obviously, your meters, first and foremost, but your instrument transformers as well, right, fall into this section. External, we're talking about transformers external to the meter, not the meter's internal transformers. Integrated meter communication devices, service switches, right, your remote disconnect switches, demanded interval registers, right? Any other measurement devices not already listed, you know, integrated or external to the meter, and then other non-energy measurement devices in our meter circuit as well. So this is where ANSI C12.1 Section 5 focuses, right? So, and one point I want to bring up. Yes, ma'am.
Oh. You might answer this on this slide, but a question just came in. What is the difference between series parallel and true service testing?
Timing is everything. Yeah, great question. So yeah, I was actually going to get into that, Andy. So the main difference between true three-phase and series parallel testing, if you've ever seen a vector diagram where, you know, it shows the three phases of a meter at, you know, equally spaced at 120 degrees each phase. In a true three-phase service, that's what you have. You have true three-phase voltage and true three-phase current on the meter. And this is a timely discussion, actually. If you look at a series parallel, a meter that is under a series parallel service, if you look at that vector diagram, you're lighting up all three of the current phases, but they would all be laying on top of each other if you looked at it in a vector diagram. So they would all just be sitting right on top of each other. You wouldn't have the full 360-degree circle. So, and that's a great question because, you know, there's been a lot of conversation lately about, you know, when I'm accuracy testing my meters in my meter shop, do I have to do it on a true three-phase test board, or can I use a series parallel test board? And the answer is that, you know, ANSI, you know, you see at the bottom here, makes no mention of a true three-phase service testing requirement in Section 5, and it doesn't reference any testing in Section 4. Okay, so based on that, we say no. Series parallel testing is perfectly acceptable. And, there has been plenty of talk about, Ansi making a push, and I think Tom Lawton and John Williams are on with us. They sit on the committee and they may be able to elaborate on this a little further, but there has been some talk about Ansi pushing towards, wanting to test meters in the meter shop always under a true three-phase service. But right now, that is not the case. You can see in 50.11, new metering devices placed in the service should meet the provisions as set forth in the section prior to being placed in the service. You can read through that, or 100% tested by the manufacturer. All metering device equipment shall be thoroughly inspected at the time of installation to assure safe and accurate operation. But they don't get into, you must test three-phase versus series parallel.
Hey,
and then,
hey, John.
also want to.
Hey, John,
Sure,
if I could just amplify a little bit, there's two things going on with Ansi right now. One, we are working on, there is an active working group for a field testing standard. Right now, the intention is that it's going to be a guideline as opposed to a standard, but that could change. But we are working on it because Ansi had never addressed field testing before, as you mentioned. The other thing is we do talk about true three-phase testing. Ansi in C12.1 in Section 5, we had never actually said anything about, we had only really ever talked about series parallel. And that seemed kind of silly that we wouldn't, that we would not acknowledge and that we would not approve true three-phase testing. So in the last publication, the 2015 version of Ansi C12.1, we basically talk about true three-phase testing for type testing of meters. So if you're doing type testing, if the manufacturer is doing type testing of a three-phase meter, we're asking them to do that as a true three-phase test. However, that's not the case for the meter testing that's going on in utilities shops. We basically took out the part about series parallel, so the implication is series parallel is that both are okay, series parallel or true three-phase. You can do it either way that you want. We kind of stay mute about the topic, so that way nobody says, oh, well, Ansi says I can only do series parallel. Oh, Ansi says I can only do true three-phase. No, that's not the case. In your shop, you can do either one that you want, but for type testing of meters, we do specify the true three-phase, which is what you would want. When the meter manufacturer is coming out with a new meter, we want them to check it in a true three-phase service. All right?
Sure. Great. Thank you, Tom. Valuable input there.
John, I'm not sure if you addressed
Andy.
this because I'm doing a lot of the behind the scenes here and answering people.
Sure.
So this question came in, what is the industry standard accuracy tolerance when testing a meter for accuracy?
0.5%, right? Correct me if I'm wrong. Anybody out there? Should be 0.5%.
Well, there's three current ratings, 0.5, 0.2, and 0.1 available. So, but I guess if you were saying the majority of them, I would assume would be at the 0.5 level.
Right. Thank you, John. Thank you. Yep. And then one last point about the series parallel testing too. I know a lot of meter shops that I've been into, large meter shops for really large investor-owned utilities. They have a ton of series parallel test boards, right? So they're not just going to throw all those, test boards in the trash and say, oh, Ansi wants us to convert over to three-phase. We're going to do that. So just another thing to add to Tom's point there. A lot of utilities do test, series parallel, and it's perfectly acceptable for meter testing. All right. Good. So in Canada, I know we always have a couple of Canadian utilities that join us here. So just wanted to touch base on, Measurement Canada real quick. So it's a little different in Canada. So everything is kind of controlled by Measurement Canada. And Measurement Canada, talks about being able to seal a meter, right? So a good meter that can go out into the field is a sealed meter. So in Canada, meters can only be sealed by Measurement Canada or a meter service provider approved and accredited by Measurement Canada to do so, first and foremost. They can only be sealed on a Measurement Canada approved test console. So Measurement Canada wants to make sure that you are doing it on a test console that is valid and accurate, right? Meter shops have to be climate controlled. They requested, at least anyhow, that you have a good dust filtering system. Meters are segregated into batches or family groups. Family groups consist of meters in the identical type, all made during the same production run at the manufacturer's factory. And then in some cases, energy meters, energy only meters like 2S sample testing on a smaller group of meters can be performed. If roughly 95% of the sample meters pass, the entire batch of family group of meters can be granted a seal extension, such as from 6 years to 8 years or from 10 years to 12. And then only Measurement Canada approved seals can be used. So that's another point to make there. Yes, ma'am.
Coming in, can a demand or 4-quadrant meter qualify for a seal extension?
That sounds like a Canada question. Yeah, that sounds like a Canada question, actually. All right, Jim McGill, are you on with us? Our Canadian Regional Manager, Jim McGill?
I am here, yes.
Excellent. So, Jim, I think the answer to that is that, any 4-quadrant or demand meter, if it's got a seal, it's got a fixed seal life, right? So it would have to be re-verified and retested at that point, right?
That's right. There's no seal extensions meters. They're all used for not like a 2S meter that might stay out there for 25 years on the same place. So at the end of that seal life that's granted to the meter when it's either manufactured or re-verified, at the end of that seal life, it has to be retested, recalibrated, and resealed. So the answer is no, it can't qualify for a seal extension. Hope that helps.
Perfect. Thank you, Jim. Appreciate it. Thank you. Hopefully that answered the question. Let us know if it did not, please.
I got a thumbs up there. Thank you, guys.
Excellent. Cool. Okay. So again, does anybody, before I move on here, are there any other questions as they pertain to, ANSI C12.1 that anybody wants to ask while we have a few folks? Hopefully we can get you the answer right now. If not, we can always dig into it, as I said, and come back to you. But did anybody have any other questions on ANSI C12.1? If not, I will move forward. All right, I am going to progress. So, obviously in today's world, it's different than it was. Those of you who have been around for a long time doing shop testing, in the AMI world especially, things are different now, right? And metering operations has so much more on their plate that they have to be concerned with. It used to always make me giggle a little bit when I'd hear people say, oh yeah, we're going to be going AMI. Life's going to be getting super easy. We don't have to worry about much. Like, oh no, your workload is about to quadruple, I'm sure. Because let's face it, electromechanical meters typically lasted 30 years or more, right? And we're finding out that electronic meters have a lifespan of roughly about 15 years. And given the, the pace of technology advances in metering, they're not expected to last much longer than this. And that's pretty much so what we're seeing. I mean, there are several, I know a few large utilities right now who were early adopters of AMI. And they are currently working on their second round of AMI deployment and pulling out their initial meters and putting in new meters. And some of them are even going with completely new technology. So, what does this mean? This means entire systems are envisioned to be exchanged every 15 years or so. And in the interim, the meter population and communication network inherent to the infrastructure has to be maintained. And a lot of that needs to happen in the meter shop as part of your testing protocols, right? So, meter communication, meter data management became now as important to metering operations as meter accuracy, right? Again, remember before it used to just be all you worried about was testing the accuracy of the meter in your shop. That is not the case anymore, as you all know. Firmware upgrades, firmware stability, cybersecurity have all become increasingly important to metering departments. I'm sure you guys all spend a good bit of time worrying about those three things. And, we talked about this a little bit in our presentation a couple of weeks ago that Tom and I did on hot sockets. Meters are being replaced at a far faster pace, obviously, than the meter sockets out there. So, it brings things like hot socket issues to the forefront. More of a field issue, but again, just, more stuff that metering operations needs to be concerned about. So, metering operations today, you're responsible for, reviewing those ANSI tests, right? And performing some, maybe all of those ANSI tests, right? Depending on what it is that your utility wants to do. Accuracy tests, that's never going to change. You'll always accuracy test the meter, and you've been doing that forever. But now you have to worry about performing meter functionality testing on new and returned AMI meters, right? And that's an important point to make. Not just the new ones, but those ones coming back from the field that need to be upgraded, have the right firmware. You need to test all those again. So again, the workload has really expanded for metering operations, especially in the meter shop. Register and communication module, energy measurement comparisons, things of that nature. Now you guys have to worry about disconnect and reconnect functionality, right? It's a great tool and it's fantastic, but it's something that needs to be tested. Outage performance, how well does your meter perform in an outage? Can you still communicate with it when it comes back? Remember, like I said, there's that issue where, we had that slight voltage blip and could have lost communication to 50,000 meters out there that would have just been orphaned, right? So, meter communications performance, insanely important, right? Also, as it pertains to things like antennas, are you getting good RF signals off your meters? Again, stuff that needs to be tested in the shop. Consumer safety and combating real and perceived issues. In the early stages of AMI deployment, we all heard the stories about that, worrying about, RF and are our meters giving these people cancer, everybody was worrying about, and, so it was typically the meter shop guys who had to combat a lot of that, right? So, and then there's always the near continuous research into the next technology and the next deployment. That doesn't seem to end. I just saw at one of the last meter conferences I was at before COVID. It was one of the meter manufacturing conferences, and one of the large utilities who had been deployed, they were an early adopter of AMI. I was surprised to see them out there because it was a meter manufacturers conference that I know they don't have. They don't use those types of meters. But yeah, they were working on investigation into their next generation of technology, where they were going to head next for their next batch of AMI. So there's typically four areas, four processes, I'll say, that every meter shop needs to think about, especially as you're talking about testing for new technology. Any new technology that you're deploying into the field, there are really four types of validation that you want to perform on your meters, right? So the first one is certification testing. And that's typically not going to be the most detailed testing that we're going to perform on a meter, right? The goal of this is just to determine, does this meter, if I'm looking at this new technology, does this meter have the features that I'm looking for, right? The manufacturer says it has it, does it do it? I want to test it. I want to make sure that it does what the manufacturer says. It's not super in-depth testing, but what we want to do is make sure that, the new technology is working as advertised, and we're going to test that in our meter shop, right? So, and then things we have to think about here are, what are our backup plans? What if we start deploying these meters and we find some issues? How well does the meter under consideration handle other communications protocols? Should the primary protocol fail? That's a really important one. Can you add an antenna to the meter? Things of that nature. Cellular solutions. Can you add a cellular solution? Can you use a power line carrier solution, perhaps, if you have meters that are in difficult areas to communicate with, right? So certification testing is kind of more that first level, just high level testing that you're going to do. Where you really get into the meat of things is when you get into your first article testing, okay? And that's going to be your most detailed testing that you're going to perform on your meters. And utilities, you guys have to realize that a lot of times what you're getting from your meter manufacturers are a series of first article meters, a lot of them themselves, right? So, as you guys are going through, and some of you have been through AMI deployment and have been deployed for a long time, still that you still get meters, I'm sure, that you now get that are different than they were when you first started deployment. The initial meters that you were getting, whether it be in the firmware and the communications, whatever it may be, are different. They may have different diodes in them or whatever it may be, but there's 9 times out of 10, there's something different about those meters. So you have to continually test, and first article testing is really where you're going to do your deep dive. And we'll talk some more about first article testing in depth. And then pilot testing, that's going to allow you guys to test the entire system and begin to start and fill some process holes that you may identify, right? Do any of your internal systems need to be upgraded for testing, right? Or augmented to allow the system the ability to handle the stress of an AMI deployment, right? If you haven't deployed AMI and you're getting ready to deploy AMI, is your system and processes going to be capable of handling that stress? And then finally, acceptance testing, is going to be part of your pilot testing. But that never really ends, right? Acceptance testing is something that you guys do throughout the life cycle of the meters, for sure. So some of the equipment that you're going to use throughout all these phases is, you want to be thinking about, everybody obviously needs to have meter accuracy test boards, first and foremost. Those come in, a couple of different types, right? We talked about 3-phase boards versus series parallel boards. It's really just a decision for the utility. It's a matter of budget. Typically, a 3-phase test board does cost rough and tough double what a series parallel test board costs. But if you don't need to spend the extra money, if you're a smaller utility, why spend it, right? So if you're a larger utility and you want to do true 3-phase testing, by all means, it's worth the extra spend if that's what you want. And then you can also have what we call functional test boards or meter qualification boards. TESCO, by the way, did coin that term, meter qualification boards, MQB. So you guys are probably all familiar with that at that point. That did start with TESCO. We've been doing meter qualification equipment for a long, long time. It started out with just warm-up boards, and warm-up boards are essentially just, you apply some voltage and current just to power up a meter so you can communicate with it, see what it's doing. Excuse me, meter qualification boards take it that step further, and those come in a couple of different varieties as well. You can get meter qualification boards depending on your needs that are, single phase or apply series parallel current to the meter, or true 3-phase if you want true 3-phase, and they're available to suit any budget, and there's a couple of different manufacturers. We feel we're the best at this because this is what we've always done. We've learned a whole heck of a lot. Meter qualification boards have become pretty advanced over time. Right now, our next generation of boards, you can apply different harmonics and waveforms to meters, which is, really cool. So you guys may know, hey, you have a new meter that you want to validate or some new technology. You can now say, hey, you know what? I know in this one area of my population, I have these crazy harmonics going on. I want to replicate that on this new meter and see how well this meter performs. So those are the kind of things you can do now with meter qualification boards. Plus, we're going to talk about test sequencing in a little bit. You can use software to program test sequences that'll automate a lot of this for you too and run through that as well. And then you have meter engineering demand boards. They kind of sit in between. Those are, if you want to do demand testing, those have an accuracy standard in them, but it's like a 1% accuracy standard typically. You guys who are doing demand testing in the past, you may even have an older demand board, which had the golden meter that everything was compared against for demand testing. People still do use those. We actually sell them. And then lastly, meter farms. Meter farms are really, really important. Your meter farm, and there's a picture of one here, is, I'm not trying to make a sales pitch here, but a meter farm is meant to be a scaled down representation of your overall meter population. And where a meter farm really, really comes in handy is after you've gotten into deployment and even post deployment, because I said things are going to constantly change. So, when that vendor comes to you and says, hey, we have a new firmware revision, we want to push out to your population of 150,000 meters, you can say, oh, no, we're not. We're going to load up some of those meters in my meter farm. And I'm going to also load up some of the meters that I know I already have deployed with this firmware and this communication module that I know work well and I have no issues with. And I'm going to do some comparison testing. I'm going to make sure everything is doing what it's supposed to do, right? And these are meant to be outside. It's still part of the meter shop. This all falls under meter shop testing, but these are meant to be outside. You want these in the weather, in the rain, in the snow, in the ice, in the hot sun baking on them, depending where you are, right? So, meter farms are also a really, really important tool. But again, meant to act as just a scaled down representation. So you have a test bed for testing things as new features come out in meters. You can deploy them with some confidence, at least. So you don't have those big uh-ohs when, meters get out into the field and all of a sudden you have, some number of meters that no longer communicate because of some anomaly, right? So, and then also, it's a good time to think in your meter shop as well about, your asset management system and your record system, right? How robust are those, as far as, handling your test data? Are they, because, in today's world, remember, it's for you guys in the meter shop, it's not just about the accuracy testing of the meter. You guys need to track communications modules and firmware revisions and passwords and all this other stuff that needs to be tracked if as you are looking at new technology of meters, it is a good time to really examine your meter record and asset system to make sure that it's robust enough to provide you with everything you need it to do. Okay. So let's talk a little bit more about first article testing again. Here we're looking at everything. This is where we start with the Ansi tests, maybe even the Ansi folder from the manufacturer, those 44 tests that I showed you. You may want to look at some of those and do some of that testing. But again, you don't want to take anything for granted here. We're going to be, in accuracy tests at, light loads, rated loads, checking performance of voltage, sags and swells. How does my meter do if I all of a sudden have a voltage sag on the A phase, you want to make sure that that meter still communicates, that it still, meters accurately, all this stuff that you get a voltage alarm back, right? This is all what you want to be doing in first article testing, disconnecting under load, the ability to reconnect. And also doing that with backfeed. That's another thing you guys want to think about, right? Because, you may have some stray back voltages on your meters out there and you don't want any unintended closures of your remote service switch, right? Because of backfeed. So you want to test that because we've seen that before in the past where you test the disconnect switch, but you didn't test it under backfeed and you're finding these disconnect switches that are closing up on you under back voltages. So you really want to check everything here. Again, a lot of utilities aren't really set up to do a full battery of FAT testing, but it is important. And I think every utility really should think about this, especially no ifs, ands, or buts about it if you are looking at deploying new technology. I mean, it's something that we provide. We recently finished up one for a utility and it went really well for them. They sent them to us, and because there's things we did, hot socket testing, things of that nature on our hot socket simulation fixture in the meter shop. But now they have their sister utility is deploying AMI in another state now, and we're going to be doing FAT testing for those meters. And actually, John Williams, I think you're on. Maybe, I don't know, maybe you can elaborate a little bit just on some of the things that you've seen utilities doing in FAT testing that
Yeah,
Uh,
we've done
sure,
for
John. Yeah, well, as John mentioned, one of the things with this type of testing that we've seen at least is a lot of the utilities that are requiring this type of testing are either required by their UC or by their own policies to have kind of a third-party verification of specifications and test results they might get from meter manufacturers, right? Not that they necessarily don't trust them, but it's just a either a legal or procedural thing that they need a third-party verification. So as John mentioned, a lot of the testing that we've done before, and you see a lot of in this type of testing, is having to do with your standard ANSI tests, not just for accuracy, as John mentioned, but you go through the environmental testing, the weathering, the temperature cycling, high voltages, low voltages. But at the same time, as John mentioned also, is a lot of these folks are looking at problems that they've experienced before, not necessarily with the old meters, but with the conditions and different problems that they might see in the applications of meters in different either commercial, industrial applications. For instance, high voltage susceptibility for like ferro-resonant conditions. We've been asked to come up with kind of a testing criteria for that in simulation, which is always a lot of fun for my interns when I put them on the test to say turn the voltage up until the meter blows up, and they get in their riot gear and stuff waiting for explosions to happen, but also with hot socket conditions, both with simulation of arcing to the meter jaws to see if there's any when does the meter, under what condition would the meter fail? Is it an electromagnetic pulse kind of thing that gets into the meter and damages it? Is it the heat conditions? Also checking just the heat itself, right? So you can check meter stab temperatures, melt points of the plastics being used by the meters, like what materials they're using, and is it going to survive hot socket conditions such that it's not going to create a more a hazardous condition. And also check, I know a lot of folks out there are currently using their AMI MR meters to check for hot sockets using the temperature sensor inside the meter, right? So you might want to do a test there where, you know, especially if you're changing from one meter to another, or you're just new to the electronic meters, using that function and raising the temperature of the individual meter stabs to a, you know, a not normal temperature level, and then reading back that temperature sensor through your network to see when you can consider it a trouble spot where you might want to roll a truck, right? There's also, as John mentioned, disconnect testing, disconnect under load, right? Because we all know, you know, it's not always the case where you're going to be opening up disconnects when there's no load on the load side of the meter. So you want to make sure you're able to test all those different conditions, and just, you know, go out to your folks that go out into the field and look at these different service locations. What are the problems they run into? What are the things that they'd like to make sure that any new meter we put out there can withstand this type of situation, whether it be an environmental condition or electrical condition or a different fault type of condition. I referred to a ferro-resonant condition earlier, and that came to us through one of our customers to test for that, because it's a I could go on for a long time on that, but there's papers out there that describe that situation. Typically, it's in a transformer rated installation where you lose a leg or a connection into the transformer boxes, and it creates a situation where you have like ultra high voltage hit the meter, and you know, you get a lot of damage occurs from that. So you might want to test for those types of conditions as well. But again, anything and everything has usually come our way, at least as far as simulation is concerned. But those are things that I think you should consider.
Thanks, John. Appreciate it. Thank you very much. Yep. So, and shameless plug, you know, we do help utilities with that. So if any of you do, you know, have some advanced testing that you're looking to have done on any new technology, we love to chat with you about it for sure. So, but thank you, John.
And John, we have a
Appreciate it.
question that just came in. What specific types of equipment available for purchase provide the user with temperature control to test hot sockets or the meters themselves, as John Williams was just talking about?
Sure. Yeah, we have a product. I'm not aware of anything else like that. It's our 3100L hot socket simulation fixture. For those of you who were on our presentation a couple of weeks ago about hot sockets and the effects of meters under micro-arcing, that board essentially simulates micro-arcing conditions, and you can see how well a meter performs under micro-arcing. There's several utilities now and some meter manufacturers actually who we have sold those to and use those. It's a great tool. We also offer that as a service. If you guys have some meters you'd like to, you know, understand better, you know, hey, how well does this thing perform? Because remember, in hot sockets, we talked about avoiding going to catastrophic flame, right? That's what it's all about. You don't want going to flame. Flame, you know, means you're going to burn something down. So, you know, if your meter smolders and the display goes out, you know, under hot socket conditions, okay. But this board will allow you to simulate those conditions. So it's called our 3100L. Thank you, Andy, or whoever answered that question, for giving me the opportunity for another plug. So,
one other thing there, John, too, to address the question that came in. Part of the 3100L is pure temperature rise, right? So we can create a micro arc condition, which is the real reason for the hot socket condition, but we can also in a controlled manner raise the temperature of any of the 4 stabs on a residential meter, and then that way you can do your testing in comparing the actual meter stab temperature versus the temperature readback on the internal electronics.
Yep, great
And
point.
for anyone who logs in early, we have that video that actually shows a meter in the 3100 that is slowly melting, which is Tom's favorite video to watch always.
Yeah, very cool. It is
And
cool
it's on our
stuff. And
website,
John's guys love burning up meters. So, our insurance company doesn't like it too much, but our engineers and techs like it for sure. So, great question. So, and, you know, then when we get into pilot and acceptance testing protocols, right, you guys in the shop should be thinking about all of the other stuff, right? And some of this may seem silly, but it's really, really important that, you know, should happen to make sure that, you know, any deployment of any technology goes as smooth as possible, right? You know, silly things like the meter box label, right? Is the company header right, or the attributes listed on the meter label? You know, barcode, can you read the barcode on the box, on the meter itself, right? The purchase order, do the line items match everything? And is it all jiving with your meter record system, you know, so that you can appropriately track all of this stuff? And, you know, whenever you assign new firmware revisions to it or whatever it is that you do, you know, all these other little things, the meter, you know, nameplate, is that correct? Is that coming in barcoded as you want? You know, PO match between the manufacturer and utility, including, you know, individual line numbers, text format, you know, all this stuff that is going to affect how well, you know, we're able to do our job in the meter shop, right? So these are things that will just help to alleviate stress if we can test them on the front end throughout any deployment of new technology, to be a big help for us, you know, just to make our lives much simpler. You know, again, physical inspection of the meters, that's an obvious one, but some people just don't do it as thoroughly as they should, right? Does the meter have, is it supposed to have pot clips? If it does, check them. Are they there? Are they in the right position, right? T-seals, the hardware revision, all that stuff, you know. And then of course you're going to do power up inspections. You know, does the meter connect to the network? Is the display working correctly? Firmware, communications module, is that all correct, right? Validate interval data, maybe, you know, time changes, simulate time adjustments, all this stuff you want to be looking at in your pilot and acceptance testing protocols, right? Of course, we have accuracy testing listed there. That happens at every stage of the meter. You know, we got to make sure they're accurate, because that's the most important thing here, right? And then we have the service switch in here and voltage profile as well, as we talked about. So, but all these things you want to be looking at during your, you know, anytime you're running a pilot of new technology, or even just during your regular acceptance testing of new batches of meters that are coming in. These are things that you should be checking in the meter shop. Okay. So, you know, and then again, that typical acceptance testing, you know, may look like just physical inspection, just to summarize, metrology verification, right? Remote communications testing, local communications testing, remote network verification, things you can do out on your meter farm. For instance, you know, here's another great opportunity to use your meter farm to make sure all that stuff is working as it should. Alarm testing, are you getting the right alarms when you are, you know, if you get a low voltage, you know, sag or, you know, voltage swell, are you getting an alarm telling you that, you know, you get temperature alarms, all that good stuff. Voltage summary tests, you know, that's another thing you want to be thinking about. But also, you know, every meter shop should think about the process flow through their meter shop and level loading of their work. So you know, I go into a lot of meter shops, large meter shops, and, you know, typical configuration that you'll see is, you know, you have one guy or woman working 2 test boards, you know, if it's a larger, busier meter shop, and he's got a test board on each side. So there was a utility, just to tell you a quick story, that was testing like that. And, you know, they were just using the individual test board, so 2 per person. And they purchased an 8-position test board from us, and it was basically split 4 and 4. Now that operator could take a box of meters, load them up, hit run, hit go. Those meters would be testing while they're unloading the other side, loading them up with meters, hit go, then they go back to the other side. They were flying. So with one person, they were able to accomplish what it took 4 people to do. And they have been blowing through their accuracy testing, and they've been able to put those additional people that were locked down in front of WECO test boards to work in other areas. So, you know, something to think about is the loading of your meter shop. Obviously, an 8-position test board would be overkill for a small municipal utility that has 5,000 meters, right? But you do want to think about things like your functional testing. Functional testing just takes longer than accuracy testing. And we'll do a quick accuracy test demo in a minute here, but, you know, accuracy test is a 3-minute, 4-minute test, right? And you're done. It's the functional testing that takes all of the time, the upgrading of firmware, checking the display, you know, all those tests that you're going to do in the functional protocol, it's going to take longer, up to about 20 minutes sometimes, like I said. And if you have to reprogram meters, it could even be much longer than that. So you want to think about the loading in your shop. I, for one, like the idea of separating meter accuracy test boards and having separate meter qualification test boards or qualification boards just dedicated to functional testing. And those qualification boards should be, if you have a decent amount of throughput in your shop, should be multi-position boards. Because, you know, let's face it, you get a box of meters, you know, you want to be able to run through those 4 meters in a qualification test, you know, without constantly starving the guy running the accuracy test, right? So, you know, accuracy testing is going to happen much faster. I would always prefer to see a shop have a single position accuracy board and then have a multi-position meter qualification board that meters got handed off to for qualification testing. And things of that nature. So just, you know, some things to think about. Think about what the process looks like. Do you know, when you walk into your meter shop, do you have a guy who's sitting there at a test board, you know, just sitting there with his hands folded, waiting for functional testing to happen for 20 minutes, right? You know, could his time be better used somewhere else? So things to think about. There are tools that you can use as well. You know, I show our little safety disconnect here for doing the remote disconnects. You know, you can just go up to the meter with this thing and test your remote disconnects rather than having to worry about hooking up a probe to each meter. You know, so there are things you can do to help increase your productivity in a meter shop as well, which is always good to talk about. All right. So in accuracy testing, we're looking at a couple of things, right? Everybody's pretty familiar at this point. I think, you know, basic accuracy test is just full load, typically 5 pulses at test amps. Light load, typically 1 pulse at test amps, and power factor, usually about 3 pulses at test amps. And when we say test amps, that means the rated amps for testing on that meter. And, you know, look at your meter. All the information you need to test it is right on the faceplate. You know, and again, these are the kind of things you want to make sure they're all there, all very clear as part of your pilot testing program. But it tells you everything I need to know. I know, you know, this meter right here shows me TA 2.5. So I know I have to test this as a 9S meter. So I'm going to test this at 2.5 amps. So for light load, I'm going to test it at 10% of that at 0.25. The KH of this is 1.8. You know, test volts of 120. The KT is 1.8. So they're the same on this one. Sometimes they're different. You have to be aware of that. And that will really screw up a test, you know. So, you know, sometimes when you get bad results, and this is more geared towards the folks who don't have a lot of experience with meter shop testing, you know, we've all kind of ran into it at one point or another. You know, first and foremost, if you go to test a meter on a test board and you're getting bad test results, you know, does the meter need to be put into a test mode of some sort, right? So like on an A3 meter, for instance, you got to turn that little screw and put it into test mode. So, you know, just you have to be aware of these things. Do you have the correct KH and KT? That screwed us all up. I know I'm guilty of that, where I've had a meter that wants to run more pulses, you know, per rev than it should. And I thought I had it right, and I'm getting screwy test results. Double check that KH, double check that KT, make sure you have it correct in your test board.
Hey,
and then the other thing is too, yes, ma'am.
Can you, we have a question coming in here. Can you explain more detail on the KH and the KT?
I sure can, but know who could explain it better is probably my friend John Williams. John, you still with us?
Sorry. Yeah.
Yes.
Sorry, I'd pass that one on to Jim, actually.
No problem. We can work through it between us. Yeah, to use it, I'm going to give a detailed definition of, you know, and anybody else
John,
feel free to chime in.
You want to take a comment from the peanut gallery?
Yes, please. This sounds like a voice I recognize too. David Ellis. Yes. Yes. Thank you, sir. Please, David.
Yeah. My way of looking at this has always been that K sub H is some event that can be identified by a human, like a disk rotation, like a disk analog on an LCD, and K sub T represents a machine readable output, like an LED output on the face of a meter. So that's how I've thought of those two along the way. And of course, we've seen some meters where K sub H is equal to K sub T, and other meters where the K sub H is different than K sub T.
Right.
So I don't know if those thoughts are helpful, but one perspective.
No, absolutely. Thank you, Dave, for chiming in there. That's actually a really good way to look at it, actually, and I hadn't thought about it that way. So, Andy, hopefully that answered the question that came in. If not, if they, need
Justin,
some more,
just give
more
us a
detail,
thumbs up. Yep, he says that's good. Thank you.
Excellent. Cool. Thank you, Dave. Appreciate you chiming in there. Very helpful. Very helpful. Awesome. So, and then lastly, like I said, does the meter need a warm-up cycle? I know I had an issue. I was at a utility and we just installed a new test board and we're going through and we got meters, we're blowing through and testing meters and we're showing off their fancy new test board and everybody's happy and loving it. And just before I was getting ready to leave, they said, hey, let's test some of these meters here. And it was a different meter type. We put it in, bad test result. The heck's going on there? I double checked everything. I had everything set correct. What the heck is the issue? Pulled it out. You know, let me get another one of those. Maybe we just got a freak meter here. Let's put another one in. Same results. I'm like, what the heck is going on here? Something is wrong. And it turns out on that particular meter, it needed it was a 9S meter, and I forget the brand. I want to say it was an older G or something like that. But that particular meter needed a warm-up cycle for 30 seconds or whatever, just to get itself going and woken up before it would give you a good meter test. So in our test sequence in the meter test board, and I'll show you that in a second, we put in a little warm-up cycle right up front. So when they hit test, it just applied some voltage and current to the meter for 30 seconds or so, and then automatically went into its full load test, light load, and power factor testing. So I don't know if any of you have experienced that same sort of thing. I'd be shocked if you did. I can't imagine it's just me who's seen that. But yeah, that is a thing out there to think about. So if you're getting screwy test results, just some things to go back and check. Again, make sure you have that KH and KT, as Dave said. Sometimes they're the same, sometimes they're not, right? And if they're not, you have to make sure you test that you're up properly.
John?
Yes, sir.
John, this is John Carroll. Just to amplify an example that you just quoted, I have the same situation when you're doing field testing with the same type of meters where you can assume it's in test mode or not, and you're not getting a pulse output. And that in fact ends up being a phase C on your test switch. You just recycle the power and next thing you know, it comes up. The pulse will actually come up and be detected.
Yeah.
So yes,
Yep.
I've seen that too.
Yep, absolutely. Absolutely. Yeah, and those are the kind of things that'll really have you scratching your head, saying what the heck is going on here. So, but they do happen. So just things to be aware of. So this is a typical, I just wanted to show you guys real quick before we finish up here. This is, I just want to run through a quick accuracy test, and I may short some of this because we're getting a little short on time here. But this is our TMA software with our test boards that you can use. But I have a 9S meter in here, and I'm actually connected to a test board. And, all I have to do at this point is, this meter is already set up, but you can see in here where I'm calling out, okay, it's a 9S meter. I double checked. It's a class 20 meter, means it's 20 amps. It's got test amps of 2.5. The KH is 1.8. If it did have a different KT, I could go into the database here and change this particular meter, give it any information that it wants. I could input it with barcodes and all that stuff. But when I'm going to test a meter, all it's going to do, I'm going to hit my start button here, and all the information about what's going on is shown right here. So you can see right now we're getting ready to run our full load test, and it's getting ready to start testing. And you can see now it tells me everything I want to know. And regardless of what type of test board you're using, you probably have something similar where, it shows you live real time. So here's our full load test. It's saying it's an accuracy test. Here's the sine wave that we're using to run this test, and I'll talk about that in a second. But it shows me I'm running this meter right now at 120 volts across. V phase is at 0, the voltage phase is at 0, the current is at test amps at 2.5 amps, and the current phase is at 180 degrees. So, and just like that, our full load test is done. It shows us our test results right here, nice and clean. It's shows us our percentage of error at 0.035, percentage registration, depending on how you want to look at it, which I really prefer. We show both. If these were in, if the meter failed, it would show up in red, by the way, just so it's a really obvious indication that you've got a bad test here. So then it automatically goes down to the next step in this test sequence, which is light load. So now it's run the light load test, and I apologize, hang in there for a couple of seconds here because light load will take a little bit longer. You have to remember, especially on a transformer rated meter, light load is next to nothing. We're only running this right now at 0.25 amps because we're running at 10% of test amps on light load. So in a couple of seconds here, hopefully this thing will kick over, finish its light load test, give us a result, and then it'll go down to power factor where we'll actually go ahead where the power factor is swung at 50%, and it'll test the meter under power factor, and it'll run 3 pulses for that. And I can skip any of these tests if I want and move on to the next phase. We'll give this a second here and let it switch down to power factor just so you can see this.
Well, rather than have dead air here, one of the functional tests that can be done using a meter farm, if I can go back, is to test your outage management system if you have one. So a lot of utilities have a lot of money invested in an outage management system. You should be able to go out and turn off a panel on your meter farm, and your OMS should recognize that those meters just went offline. So, I mean, just another test you can do with a meter farm.
Yep, absolutely. Absolutely. Good point, Jim. Thank you. Thank you.
I have
So, yep,
another
and you can
quick
see it
question.
automatically pop down. Sure, go ahead.
How would you save your ANSI test results and print them?
Sure. So from here, I have 2 options. I can just hit this nice little print button here, and it'll print out a nice little PDF report. Essentially what you're seeing here, all this good information. It'll show the serial number, the form, the KH, everything about it, the date, who it was, right? It shows me all this good stuff. It'll have all of my test results, and we're just about finished here on power factor. It'll show me my weighted average for them, which I could change in here if I wanted to. But so that's option 1. I can print this out, send it to a printer, or just print it as a PDF, whatever I wanted to do. Option 2, obviously, is that this now gets stored in my database. And, you know, if there's a handshake between whatever the database is here. So this is TMA, this database, and it can be used as a standalone database application. So I can store all my meters in TMA if I wanted to. If I'm a smaller utility, I may want to do that and just use this as my meter record system. This particular utility here comes with the meter test board. You buy a meter test board. This is just included, so you get that for free. So you can use this as your meter database. But you know, if you're a larger utility and you're dealing with a ton of meters, you're going to want to make a handshake between this and whatever your system of record is. Your, you know, whether that's your CIS system or whatever your meter record system is, where that test data is permanently stored. But it will capture all of that information that you care about. Again, the serial number, the date, who tested it. You know, and every utility has, you know, different things that they want to capture, but all this information I'm sure will be in there, the percentage of error, percentage of registration, the voltage that it was ran at, all that good stuff. So hopefully that answered the question for you. So, and all we did here, you know, just something for you guys to think about is, you know, as you're doing all this functional testing, especially in today's world, you can go ahead and add in. So I can add here if I wanted to. Let's say I wanted to do a voltage Sag test. I can go in here and select what I want, and I set this one up already ahead of time. Yep, here it is. This one here. So you can see I set this particular waveform up to run voltage at 102 volts. Maybe I want to know, part of my functional test is, hey, am I getting a voltage sag alarm back from my meter, right? That's something I'm going to want to test as part of functional testing. So now I can put that in there, right? He's in there, just say update, not my clock, sorry. Update, that guy's in there now. Now, you know, if I ran that same test again, it would go through, run full load, light load, power factor, and then jump down to this voltage sag test. I can take it and I can move it up to the top if I wanted to do that first, you know, whatever you want to do. So we've seen these test scripts build out that are, you know, 50, 60 lines long, so that, you know, if you want to, part of your functional test may be to check the display. So you just leave it run with some current and voltage on there, and you can just skip test and go down to the next sequence. So just something I want to show you guys should think about sequence testing. Yes.
Is there a common, like, what's the most common test sequence when doing an accuracy test on an electric meter?
Sure. Yeah. So it's just as we have it here. If you're just talking about accuracy testing, it's just going to be full load, you know, light load, and then power factor. That's the typical sequence. You don't always have to run in that order. That's typically how we always do it. But that's what you'll see is full load, light load, power factor every time. So let me know if that didn't properly answer that question. So I apologize. Looks like I went a little long here, so I will shut up and
we'll
see
have
if
a few
you guys
questions coming in.
have any questions. Yes. So let's see if we can field some questions real quick. So
Absolutely.
Yep.
And just a reminder, if you guys got to go, you got another meeting or something, we will send out that rewind email. If you do not get that, you can always contact us or go to our webpage and get that from our TESCO Tuesdays. The next question I have, when a member asks for their meter to be tested, how many times would you recommend testing it to represent accurate or average results?
How many times? Tom, do you want to take a stab at that one?
Is Tom there? Is he on
I'm
mute?
muted. Maybe muted.
Okay, how's that? Can you hear me now?
Now we can
There we
hear
go.
you.
All right.
There we go.
So typically what you want to do with I mean, every utility has a different process, and for utilities that are governed by the utility commissions, there is a mandated process. Typically, the customer has the right to witness the test. Some utilities like to do or will only do the test out at the customer sites. Some, on the other hand, will only do it in their meter shop in a controlled environment. Whichever way that you want to do it, typically there is a full load test done and a light load test done, and sometimes there is also a 50% power factor done. But for a complaint test, more traditionally, I will typically see a full load and a light load. The weighted average is typically used, doesn't have to be used, but is typically used where it's 4 times the full load plus the light load divided by 5 gives you your weighted average. Others say no, if either the full load or the light load falls out, and assuming a residential customer falls out of plus or minus 2%, there is a problem. Also, I've also seen some utilities, again, it depends on your process, some utilities will rebate a customer if it's over 100.0 at all, they will provide a rebate. But the typical test, which was the original question, is a full load test and a light load test. If your utility does a 50% power factor for complaint tests, that is also obviously okay as well. All right, does that answer the question, Andy?
I hope so. I will see. I don't know if Jocelyn's still on. You want to let us know
Otherwise,
if that
just reach
helps?
out to me later, whoever asked the question.
Yeah,
Yep.
definitely.
Thank you. Thank you, Tom. Thank you, Tom.
All right.
Appreciate it. Yeah. So, and you can change that weighted average too, by the way, just so you know, like in the software while I was showing you, you can, there's actually means that you can set that to be whatever you want it to be. Your utility does something different.
Excellent. I have more questions coming in here. Why should I test meters when the meter manufacturer sends me their test results?
Great question. Because you want to make sure that you're keeping them honest is the short answer. I don't know if anybody wants to add anything to it. You guys, especially at the utilities, if anybody at any of the utilities wants to add anything to it, but I mean, that's the short answer, right? You want to make sure that what you're getting is really good, right? And then nothing changed in shipping.
They're tested by the manufacturer at the factory, right? And then they go through a shipping process and they end up in your warehouse and then they get moved into your test shop. So after all that jostling around, you want to at least do a random sample test to make sure there's been no damage in transport. So that's one very good reason.
Yep. As we stated in the beginning, why do we test? Because things do fail.
Absolutely. All right. Thanks, guys. Let's see here. Going down the list, I'm trying to get to everybody too. So if I haven't gotten to your question yet, just hang on. We're going through. I got a lot in that during your testing section there. Does Ansi recommend a certain number of meter pulses that a meter should be tested at on full load, light load, and power factor?
Yes, and somebody correct me if I'm wrong, but I believe it is 5 full load, 1 light load, 3 power factor. And I don't know if that's dependent on the meter or not, but somebody can chime in if I'm misstating that, please.
Yeah, I'm not sure if it's absolutely stated within any of the ANSI standards, but I'm on a committee for testing or writing test specification standards for some newer type meters, and we actually did put that into our standard because it had come up. The bottom line is there's a mathematical equation. If anybody's interested in it, I can send that to you. But there's an equation that you can use to get the right number of significant digits to make sure that your test results can be compared to the meter manufacturer's quoted accuracy. And so bottom line is it's a combination of how much power you put on the meter plus the amount of time you want to spend testing meters and the case of H level of the pulse output.
All right. Thanks, John.
Thanks, John. Thank you.
Next one, if I have a KH of 1, how many pulses should I use for each load? Is that you again, John Williams?
Yeah, sure.
You're popular today.
Yeah, and I've been told this topic is boring when I start talking about all the mathematical formulas and stuff. So I don't want to bore the whole crowd. But again, it goes to the number of significant digits, right? So typically, if you're looking at a test and you're looking at registration, you want to test to, let's say, 5 significant digits, right? So it's 100 point something something, right? So within that calculation, you have to make sure you keep that consistent through the calculation, which means you have to have a certain number of pulses to meet that requirement. And it's usually, if you do that calculation, it's usually a lot more pulses than most folks test and use in their meter shops, because it extends the timing of the tests. The one thing I would warn against and to keep aware of is that I would tend to stay away from one pulse test if you can. And if that meets your requirements in terms of test time and throughput through your shop. But we have found here, and we've done a lot of testing over the years on the accuracy of the meter pulse output and the gap between consecutive pulses. So any one particular pulse has a much higher error value than if you averaged over, say, 3 pulses, right? So typically over 3 pulses, the output pulse accuracy is far better. So just doing 3 pulses instead of 1 is going to get you better and more consistent results.
Makes sense. Yep.
Okay.
Thanks,
and
Joe.
I don't think anyone fell asleep there, so good job. Is there a next question? Sorry, I have to pick on you guys. Is there a Nist standard that requires the manufacturer to provide a copy of their calibration report with their test report? You guys are giving us good questions today. Thank you, guys.
Yeah.
Yeah. So
Tom, do you know, or John? Yeah.
Yeah. So typically, I don't know if there's a requirement, and again, it all depends on where the data is being reported to. If it's going to a utility commission or whatever, then typically the boards themselves are your test boards themselves are going to be calibrated, right? And then well, at least we do.
Back to Nist.
Yeah, we show the Nist traceability in our documentation.
Right.
And then you can take that record, if it's required, you can take that Nist traceability record for the calibration of the test equipment and use that to certify the testing of the meters, right? It's a transfer.
Just a clarification on that, John. Nist is the U.S. version of our, it's our national standards lab. The requirement for Ansi is you must be traceable back to an international lab. So in Canada, that would be Measurement Canada. For here, it would be Nist. Actually, not Measurement Canada. It would be, what's their acronym? Drawing a blank. Anyway, in each country, there is one. You have to be traceable back to an international standard. As far as the requirement for the manufacturer to give you that, for traceability purposes, yes. If you're getting accuracy results on an incoming shipment of meters, you can absolutely request for the traceability, although that's not a Nist requirement, but that is if you ask for that traceability of the calibration, just as any of your customers could ask you and say, hey, you tested my meter, I'd like to see how that is traceable. How did you calibrate it and how is it traceable? So yeah, you always have to show the traceability. And it's not to Nist, but to an international standard.
Thank you.
Okay, I have another ANSI question coming in. What are the ANSI C12.19 tables? Am I asking that right? C-12.19?
Mm-hmm.
Okay.
Those are the tables that are.
So anybody want to fill that one?
Yeah, those are the tables that are in the meter. Every manufacturer does it slightly differently, which I know that doesn't make it for a standard. But
right, each manufacturer has unique tables, right, Tom? I think each manufacturer does have unique tables, right? Yeah.
They do. I mean, they try and get them as close as possible, but this standard came into effect after the manufacturers had already created their firmware. So ANSI is a voluntary standard. It must be approved by everybody, and it has to be a unanimous consent. If we get a no vote, we have to get that person. We have to understand what their disagreement is with the standard, and we have to get everybody in agreement. So NCC 1219 is a table about the tables in the firmware in the meter.
Thank you.
Okay. Thank you, Tom. Next question, what is the difference between the functional test boards mentioned in the presentation?
Sure. So, well, I could talk about this forever, but I'll try and keep it short and sweet. Functional test boards, typically three different types, either single phase, series parallel, or true three phase, depending on what's important to you. And you can do hybrid versions of a functional test board too, where you may have some socket positions that are true three phase, some are just single phase. You may want to mix some sockets that are accuracy test boards with that. Single position is, what you may see in a smaller shop or just for checking in a meter even. You can also do multi-position boards where you have individual socket control over every single socket. So I can run different meters in every single socket, so they're all independent. Or I can have a configuration, if I'm more budget conscious, that is, has a master socket and then subordinate sockets that do whatever command I give to the master socket. So there's a couple of different variations of them, but we build them to suit your needs. So yeah, if anybody has any questions or want to talk further about that, by all means, please email me or your local regional manager, and we can have a more in-depth discussion if you like.
Okay, I have just a few more here. We have a small, and keep them coming. If you guys have them, we can stay on a little bit. I know we're way over, but we'll be happy to answer any questions you guys have. One came in from someone from a small municipal. If I decide on a test station for my shop, can TESCO provide us with any training?
Sure, absolutely. Yeah, we typically include that with the purchase of a test board. For us, it's usually our regional manager. A lot of you guys, most of you probably know the regional managers in your area. They are all very capable. So, typically what we'll do is, they'll come out, spend some time with you, go through training, make sure you're good on the board. Obviously now with COVID, we've been doing a lot of remote training sessions. So we do that as well, where, we may do it over a WebEx or something like that, if that's what's required. And maybe I'll get involved, or even a John Williams or somebody on his team gets involved. But yeah, we absolutely make sure that you're comfortable with the test board and able to get off and running. So it's pretty simple. So, but yes, we would include that for you.
Excellent. Thank you, John. Let's see, this could be the last one unless anyone has anything else. When you get the test report from the manufacturer, I understand retesting to double check those results. Are there some of those tests that come into the manufacturer test report that you recommend not to double check because they could be considered destructive tests for the meter?
Yeah, I guess that's really depends on the utility, right? And
John, you would really only do accuracy tests on the meters coming in from the manufacturer for general shipments. But if you are approving a meter for the very first time and you were doing a first article test of that meter, I rarely see people doing any of the destructive tests, although I have seen it done. But that's atypical. So you would typically do the non-destructive tests. If you're concerned about it, or you're going to put them out for an AMI deployment, you may take a couple of boxes of those meters and you may contract out to have some of the destructive tests done. But that's only on first article, approval.
Yep.
All right. Are there any other questions out there? Let's see. Okay, guys, I just put the link in the chat where you can find all our info on TESCO Tuesdays, including our rewind sessions, which is a recorded copy of all of us and your questions. There's also a slide share if you just want the presentation portion. And the next 2 sessions that are coming up are preparing for AMI deployment with Jim McGill, which you heard from on this session, who's our Canadian sales manager up there. And also John Williams was on our call today. You heard from him. He'll be discussing communication equipment on April 13th. And if you're not signed up already, you can go to our website to do that. Be sure you don't miss out on those. And we'll actually be sending a survey out tomorrow and ask you guys what you're thinking for next session. What do you guys want to see? What do you guys want to learn? What do you want to hear from us? And then we'll get those dates in there for you guys. And also one last plug is our users group is July 18th to 21st in Philadelphia. We are open. We are taking registrations. That information will be on the Rewind emails as well, or you can find it on our website. And you can learn anything and everything about our test boards and discuss with other utilities. And it's a great networking opportunity. So we hope you guys will come to that. We hope to see you there. It'll, get more input and insights to our, equipment and software and things like that. So any questions you guys have, feel free to throw them our way. As you heard from everybody today, thank you, John, and thank you, Tom and John Williams and Jim McGill and everybody who chipped in there. Appreciate all your support, guys, and have a great week. Okay, anybody else have anything?
Thank you, everyone. Appreciate it.
All right, guys, have a great week. We'll see you next
Thanks,
week.
everybody.
Take care.
Nice job,
Thank
folks.
you. Bye.